Hi, my name is Jaden Miner. This is my presentation on our Grignard reagent reaction that we did in the OCHEM 2 lab. First off, Grignard reagents are useful for forming carbon-carbon bonds because they create a nucleophilic carbon that can then bond with electrophilic carbons. And Grignard reagents are formed through the reaction of magnesium metal with an alkyl halide. In my group's experiment and our reaction, our starting material was 3-bromotoluene, which we then reacted with magnesium metal in the form of magnesium shavings. Those two react in a radical reaction like this. So one electron from the bromine reacts with one electron from the magnesium metal. The remaining electron is then deposited onto that carbon. The radical from the carbon then reacts with the remaining radical on the magnesium metal to then form the Grignard reagent. From here, with the Grignard reagent, the electrons in this bond attack this carbon. Magnesium and bromide leave as a leaving group. And electrons from this pi bond are then deposited on the oxygen, giving the oxygen a negative charge. We then added acid to the experiment, or to the mixture, in the form of hydrochloric acid. And a lone pair from the oxygen will then take a hydrogen, giving us a carboxylic acid product, which in this case was M-toluic acid. I forgot to mention carbon dioxide was our electrophile in our particular reaction. A couple of notes. Iodine was used to speed the formation of the Grignard reagent in our reaction. The iodine was added, and it caused a color change in the mixture. The starting materials were initially a clear liquid. The iodine then turned that reaction mixture to a dark brown color, which after heating rapidly changed color to clear and then eventually yellowed, and the final product had a yellowish orange tint to it. The CO2 was also added to the reaction in the form of dry ice. In this case, dry ice was obtained, and then the liquid Grignard reagent was poured over it, and the two reacted in that way. Two major side products that were expected to form included biaryl side products and toluene. The mechanisms for formation of these side products is as follows. A very similar radical reaction from the 3-bromotoluene with the magnesium metal, leaving a radical on the carbon. Those two radicals could then react together to form a biaryl side product. For toluene, similar beginning, radical reaction, which then reacts to form a Grignard reagent, but then instead of grabbing or attacking electrophilic carbon, this Grignard reagent, this nucleophilic carbon, would then just simply grab a proton from some proton source, be it acid or water, leaving us then with toluene. In the experiment to try and mitigate the side products that were present in the final product, after the Grignard reagent and carbon dioxide were combined, and initial separation via set funnel extraction was performed, sodium hydroxide was added to the reaction mixture. This served to deprotonate the carboxylic acid product and rendered it water soluble. Washing with water then separated out the deprotonated product into the aqueous layer and left the side products in the organic layer. Once the aqueous layer was separated out, acid was then added back in to protonate the product back to M-toluic acid, and then the product was dried. For our analysis, the expected yield was 1.35 grams, while actual yield was 0.157 grams, giving a percent yield of 11%. Some spillage of material did happen during the process. The percent yield could also have been improved through better filtration and separation. For the melting point, the literature melting point for M-toluic acid is 108.7 degrees Celsius, according to pubchem.gov, while the measured melting point was 70 to 75 degrees Celsius. Likely impurities included water due to improper drying. Analyzing the IR spectrum, I apologize for the quality. The printer at the lab was not working once again. So this is a picture from a phone. However, it is still useful. We can still analyze it. Looking at this broad peak here, it's centered at about 3,200 1/centimeters, which indicates an alcohol group. These peaks here are likely just standard carbon-carbon bonds, while these peaks here would indicate an aromatic ring. There is a distinct lack of peaks that would indicate a carbonyl group, and the carboxylic acid group would likely be more in this area. So this data together tells us that the final product was probably not a carboxylic acid as was expected, but likely some kind of alcohol. The 1H-NMR data supports this theory. These peaks here were most likely generated again by an aromatic ring, while this peak here seems likely to have been produced by an alcohol group. It's a broad peak in the proper range. So this again supports the idea that an alcohol of some kind was likely formed. Based on the IR and the NMR data, it would appear that the desired product of M-toluic acid was either not formed or not collected, but rather some kind of alcohol was obtained as the final product. So that is my presentation. I hope it was clear. Hope you enjoyed it. And thank you for the opportunity I had to work in labs. I had a really good experience, and I wish that I still could be there. But there it is. Thank you.